Okay, let's dive into this. The Sahara, green. It's kind of hard to wrap your head around, isn't it?
It really is. When you think Sahara now, it's just vastness, sand, rock, really extreme.
Exactly. Sun-baked dunes stretching forever. Forgiving isn't the word that comes to mind.
Not at all.
But now I want you to just sort of completely rewrite that image, just for a bit.
Okay.
Rewind the clock, say a few thousand years, and instead of those barren dunes, picture lush, vibrant green, teeming with life.
And that wasn't just a fantasy, was it? For thousands of years, that was North Africa's reality.
A fertile paradise. We call it the Green Sahara.
A lost world, really.
Absolutely.
Yeah.
But who were the people living there? You know, thriving in this place that's now buried under sand. What secrets did their genes hold?
And that's the crucial question, isn't it? Because their story, which we're only just uncovering thanks to some amazing science,
Right.
it might completely challenge what we thought we knew about human history, about how people moved around.
Migrations, yeah. And maybe even reveal these surprising links to cultures continents away. Like Celts, Mesopotamia. It sounds wild.
It does sound wild, but the evidence is pointing in some very interesting directions. It's a profound shift in perspective.
So that's what we're doing today, right?
Wow.
Taking a deep dive into this groundbreaking new research. Ancient DNA from the Green Sahara.
Exactly. Our mission really is to pull together the latest insights, look at it from different angles, and hopefully give you that kind of aha moment, that deeper understanding of North Africa's past, which is so often misunderstood.
Yeah. We'll look at this newly identified human lineage, try to untangle that complex genetic picture of North Africa.
And chase down those surprising echoes, those connections between these ancient people and cultures that seem totally separate.
Because you might think, you know the story, right?
Yeah.
Humans migrating out of Africa, spreading across the globe.
That standard narrative.
Yeah, that one. Yeah. But this deep dive, it feels like it's revealing a hidden chapter. A unique group that, well, it seems they largely stayed put.
Developed in isolation, more or less. Genetically, anyway.
Like a genetic island in this green sea. But then, paradoxically, their story, or maybe just whispers of it, seem to have influenced places really far away.
It just shows how much history is still buried, doesn't it? How much is waiting in our DNA to be read.
It really does. And it's a testament to these new scientific methods, like you said. Ancient DNA analysis. It's like switching on lights in dark rooms of the past.
Definitely. Challenging old assumptions, finding new narratives.
Okay, so let's set the scene properly. This vanished world, the Green Sahara. What time period are we actually talking about?
We're looking at what's called the African humid period. And this wasn't just, a couple of rainy seasons. It was a massive, sustained transformation.
Right?
Lasting thousands of years, roughly from about 14,000 years ago up to about 5,000 years ago.
Wow, 9,000 years. And what caused it? Not humans, right?
No, nothing humans did. This was planetary mechanics, subtle long-term shifts in Earth's orbit around the sun. They're called Milankovitch cycles.
Milankovitch cycles. Can you break that down a bit? Sounds complex.
Well, basically, think about Earth's orbit. It's not a perfect circle. It gets more or less elliptical over long periods. That's eccentricity.
Okay.
And the Earth's tilt on its axis. That varies, too. Obliquity. And the axis itself wobbles like a spinning top slowing down. That's precession.
Right, I think I remember that from school.
Yeah. So over tens of thousands of years, these subtle changes add up. They altered how much solar radiation hit the northern hemisphere at just the right times of year to significantly strengthen the African monsoon. It's this huge, slow, cosmic dance, but it directly changed the climate here on Earth.
So stronger monsoon means more rain pushed further north into the Sahara.
Exactly, much further north than today. And this literally transformed the landscape. It turned the arid Sahara into something incredibly hospitable.
The Green Sahara.
Truly green. Think sprawling savannas, maybe like East Africa today, dotted with big freshwater lakes, rivers flowing through, wetlands.
Wow. Not just a few oases then.
Yeah.
A whole green landscape.
A vast, vibrant, green expanse across what's now the world's largest hot desert. It's hard to overstate the difference.
And this supported a whole ecosystem.
Absolutely. Teeming with life. Animals we now only find much further south. Imagine giraffes browsing, rhinos, maybe even hippos in those lakes.
How do we know that for sure?
Well, partly from the incredible rock art these people left behind. Etched into rock shelters, cliffs, all across the Sahara.
Right, I've seen pictures. They show animals, people.
Vivid depictions, not just the big animals, but scenes of their lives. Hunting, fishing, and eventually herding animals.
Which brings us to the people.
Yeah.
So this lush environment, it obviously supported human populations. They thrived there.
They really did. They adapted incredibly well. At first, probably lots of hunting, fishing in those lakes and rivers. They made really sophisticated tools, harpoons.
Hmm.
But then, over time, a major shift happened. They started adopting this revolutionary idea, herding domesticated animals, goats, sheep,
And we know this
from the clues they left. That rock art, scattered tools, distinctive pottery fragments. These hinted at vibrant communities for a long time, gave us glimpses.
But the full story, especially who they were genetically, that was missing until recently.
Exactly. That remained elusive. We knew people were there, we knew they adapted, but their genetic identity, their connections, that was the big question mark.
And this green period lasted 9,000 years, you said. That's a huge chunk of time.
It is. And an incredibly long period of stability, relatively speaking.
Yeah.
But, well, it didn't last forever.
Right. What happened?
Around 5,000 years ago, those same orbital cycles, the Milankovitch cycles, they shifted again.
Ah.
The African monsoon weakened dramatically. The rains retreated south. The lakes dried up. The savannas withered.
And the Sahara started turning back into the desert we know.
Pretty much. An inexorable return to hyper-arid conditions.
Right.
And obviously, this huge environmental shift forced people to move. Sites were abandoned.
Like Takarkori.
Exactly like Takarkori, which then lay silent, buried by sand, preserving its secrets for millennia.
Okay, so that brings us right to it. The Takarkori revelation, unearthing this lost lineage. Where exactly is Takarkori?
It's a rock shelter deep in southwest Libya, pretty remote, near the border with Algeria, in the Caucasus Mountains region.
And it acted like a time capsule, you said.
Almost perfectly. It's a natural rock shelter, offering protection. But crucially, the conditions inside were incredibly dry.
Which is good for preservation.
Extremely good, especially for organic material. Archaeologists exploring it found the remains of 15 people, buried over a long period, from maybe 8,900 to about 4,800 years ago.
15 individuals. And some were exceptionally preserved.
2 in particular, not just skeletons, they were naturally mummified. Skin, tissues, even ligaments partially intact after 7,000 years.
Wow. Naturally mummified. How?
Just the extreme dryness and maybe the heat acting like a natural desiccant, it just stopped the decay process, essentially. These were 2 women, probably in their 40s, buried around 7,000 years ago.
That's incredible luck for science.
A huge stroke of luck. Because it meant their soft tissues and, crucially, their DNA were protected in a way that rarely happens.
Especially in the Sahara, right? You think heat, sun, temperature swings.
Yeah.
That must be terrible for DNA.
Absolutely. It's probably one of the worst environments you could imagine for DNA survival. Which is why early attempts back in 2019 only managed to get mitochondrial DNA.
Which traces the mother's line,
Right.
right? Useful, but not the whole picture.
Exactly. Like getting just one blurry snapshot. Important, but limited.
So what changed? How did they get the full picture?
Technology and methods improved dramatically. By 2025, scientists could go back, use new extraction techniques, and they focused on a specific bone.
Which one?
The petrous bone. It's this really dense, pyramid-shaped part of the skull near your inner ear.
Okay.
Its density acts like a kind of protective bunker for DNA, shielding it from degradation better than other bones.
Clever.
Very. And from the petrous bones of those 2 7,000-year-old women, they managed to sequence their whole genomes.
The whole genetic code from remains that old in that environment.
Yes. A landmark achievement. The first time complete genomes of this antiquity had been retrieved from such a hot, challenging place. It was, like you said earlier, upgrading from that blurry snapshot to a full 4K movie. Unprecedented detail.
So the 4K movie, what did it show? What was the headline?
The headline was astonishing. These individuals belonged to a previously unknown human lineage.
Completely unknown.
Largely genetically distinct from other known ancient populations. Their genomes showed basically no significant mixing with typical sub-Saharan African populations to the south.
Okay. What about North, Near East, Europe?
Very little evidence of genetic input from them either. They were effectively a lost branch of humanity that had been living right there in North Africa.
Wow. Isolated. How deep does that isolation go?
Incredibly deep. The analysis suggests their ancestors probably split off from the line leading to modern sub-Saharan Africans maybe 50,000 years ago.
50,000, that's around the time of the big out-of-Africa migrations, isn't it?
Roughly, yes. So while other groups were moving out and populating the globe, the ancestors of this Takarkori group seem to have stayed in North Africa and remained largely genetically separate for the next, 40,000 years or more? right up until these women lived 7,000 years ago.
That's staggering.
Johannes Krauss, one of the top ancient DNA researchers, called them a remnant of the genetic diversity present in northern Africa, like a pocket of ancient diversity that survived.
And this really flips a common idea on its head, doesn't it? The idea of the Green Sahara as a highway.
It does. For years, the hypothesis was that this green, fertile Sahara must have been a major corridor, a place where people from North and sub-Saharan Africa constantly met, mixed, exchanged genes.
Made sense intuitively. A habitable bridge.
You'd expect a lot of gene flow, a real melting pot in the DNA. But Takarkori tells a different story, a more nuanced one.
No genetic superhighway, then.
Not for this group, it seems. Their genomes showed really limited admixture, no significant sub-Saharan African input, very little Near Eastern or European.
So who are their closest relatives, genetically?
Interestingly, it wasn't people south of the Sahara or Europeans. It was those 15,000-year-old hunter-gatherers from Tafralt Cave in Morocco, hundreds of miles west.
Tafralt. We'll come back to them. But both Takarkori and Tafralt are distant from sub-Saharan Africans.
Equally distant, yeah. Which really reinforces this idea of a core ancient North African lineage that was surprisingly genetically contained, at least for a very long time.
But wait, there's a paradox here, right?
Yeah.
You said they found evidence these women were herders, pastoralists.
That's right. Alongside the remains, they found pottery tools, but also clear signs of animal husbandry, herding goats, sheep.
And we think those animals and the idea of herding came from outside Africa, probably the Near East.
That's the prevailing understanding, yes. The domestication happened there first.
So the culture pastoralism reached them, but the genes didn't flood in with it.
Exactly. That's the crucial point. They adopted this major cultural innovation, this whole new way of life, but there's no big wave of Near Eastern genes arriving at the same time.
So how did herding spread then, if not by people moving in large numbers?
The researchers propose it spread mainly through cultural transmission. Ideas, techniques, practices, moving between groups. Maybe small-scale interactions, trade, learning from neighbors.
Rather than large groups migrating and replacing or mixing heavily with the locals.
Precisely. Savino Durnia, one of the archaeologists, put it perfectly. They were isolated in terms of genetics, but not in cultural terms.
That's a huge insight.
Yeah.
Culture can travel without genes tagging along, essentially.
It suggests a much more complex picture of how innovations spread in the past. It wasn't always about mass migration and genetic replacement. Sometimes ideas traveled faster than people.
Does the archaeology back this up beyond just the bones?
It seems to. While pastoralism might have Near Eastern roots, the local toolkits and pottery styles at Takarkori remained distinctively North African. They weren't just copying Near Eastern styles wholesale.
So they adopted the idea but made it their own.
It's like it. Cultural adoption and local adaptation, rather than being overwhelmed by outsiders. And interestingly, there are also pottery links to sub-Saharan Africa and artifact connections to the Nile Valley.
Suggesting a network.
Exactly. A network for ideas and goods, even if large populations weren't constantly interbreeding across those connections.
And what about Neanderthal DNA? You mentioned that earlier. Does that fit the isolation picture?
Perfectly. They found traces, yes, but incredibly small amounts, about 0.15%.
Which is tiny compared to modern Eurasians.
10 times less, roughly. This suggests very limited, very ancient contact with groups who had left Africa, mixed with Neanderthals, and then maybe drifted back in much earlier. It strongly reinforces the picture of long-term genetic isolation for this core lineage.
So this is a major takeaway then. A population can keep its distinct genetic identity for millennia, even while it's actively participating in cultural exchange, adopting new technologies like herding.
Absolutely. And it means the Green Sahara wasn't necessarily this free-for-all mixing zone we might have assumed. It was a place where distinct groups could maintain their identity while still being connected culturally.
It really fills a gap in understanding Saharan prehistory. It wasn't just a bridge, it was a homeland.
A homeland for unique human groups with incredibly deep roots. The Takarkori genomes are a true landmark, revealing this lost population and reshaping how we see North Africa's role in the bigger human story.
Okay, so Takarkori gives us this incredibly ancient, isolated lineage. But that's just one piece, right? How does it fit into the broader tapestry of North African ancestry, stretching back even further and coming forward in time?
Great question. Takarkori is a key, but it unlocks a much bigger, multi-layered story. Let's zoom out.
Where do we start? How far back?
Let's go way back, maybe 60,000 years ago. We start seeing evidence for a population group in North Africa, often called ancient North Africans.
Okay, distinct from other African groups.
Genetically distinct, yes, even back then. Now, there's a fascinating debate here. Some argue they were a sibling population to Basal Eurasians.
Basal Eurasians. Those are the very early group that migrated out of Africa and formed the foundation for non-African populations, right?
Exactly. So one idea is that these ancient North Africans were closely related to them, a sister group. Another, even stronger argument is that they might have been the exact same people as Basal Eurasians, or at least part of that same ancestral pool before the main out of Africa push.
So potentially the ancestors of people who left Africa and people who stayed in North Africa were part of the same metapopulation for a time.
That's the idea being explored, and it's proposed that this very early North African population largely belonged to the paternal DNA lineage E, which is a really useful marker for tracking population movements over time.
Okay, so that's the deep foundation 60,000 years ago. What comes next?
Fast forward quite a bit to about 20,000 years ago, up to maybe 10,000 years ago, we see the rise of the Iberomaurusian culture.
Iberomaurusian. I recognize that name. They were in the Maghreb, Morocco, Algeria.
Exactly, Western North Africa. They were hunter-gatherers, known for these very distinctive small stone tools, microlithic bladets, really finely made.
And their origins were a bit of a mystery too, weren't they? Europe, Middle East, local?
For a long time, yes. But then came ancient DNA studies, starting seriously around 2018 from Tafralt Cave in Morocco. These remains were about 14,000 to 15,000 years old.
And what did the Tafralt DNA show?
First off, it ruled out a European origin. No genetic link to European hunter-gatherers of the time.
Okay, so not from Iberia across the strait.
Doesn't look like it. Instead, the 2018 study modeled their ancestry as roughly 63.5% Natufian-like.
Natufians again. The hunter-gatherers from the Levant, near where farming started.
Right. And the other 36.5% was linked to some kind of unspecified sub-Saharan African population. So even then, it showed this deep genetic link between North Africa and the Near East way back in the Stone Age.
But unspecified African, that sounds like the same problem they had initially with other studies. They couldn't pinpoint it.
Exactly. Africa's genetic diversity is immense, and they didn't have the right ancient reference points from within North Africa itself to match that component precisely.
Until Takarkori.
Until Takarkori. The 2025 study, using the Takarkori genomes, allowed them to refine that model. Now, the Tafralt ancestry is seen as about 60.8% Natufian-like, and the remaining 39.2%. That's derived from the Takarkori-like ancestral North African population.
Ah, so Takarkori was the missing piece. It identified that unspecified African component.
Precisely. It confirmed the roughly two-thirds Levantine, one-third ancient North African mix for the Iberomaurusians and clarified who that African component was related to. It wasn't recent sub-Saharan African admixture. It was this deep, local North African lineage.
And this creates that amazing continuity you mentioned earlier.
Yeah.
Tafralt foragers 15,000 years ago, Takarkori herders 7,000 years ago, genetically linked.
An 8,000-year span. It shows this core North African population persisted through massive climate change, adapted their lifestyle from foraging to herding, but kept this strong genetic thread connecting them back to the Ice Age. Incredible resilience.
Can we trace this with those haplogroups you mentioned, the maternal and paternal lines?
Yes, they give us specific trails. On the maternal side, looking at mitochondrial DNA, we see haplogroup U6.
U6, didn't that come back to Africa?
That's right. It originated in Western Eurasia maybe 35,000 years ago. Then, a group carrying it migrated back into North Africa. The specific version found in Tafralt, U6A, seems to have diversified within North Africa, and the Iberomaurusians might have spread it around the Maghreb.
Any others?
We also see M1, another lineage suggesting a back migration, possibly from Asia.
And the father lines, U chromosome.
All the tested Iberomaurusian males from Tafralt belong to one specific lineage, E1B1B1A1, also called EM78.
EM78, is that still around?
Very much so. It's still the predominant paternal lineage across the Maghreb today. This tells us the core paternal ancestry of North Africans has been there since at least 14,000 years ago. Remarkable continuity.
And connecting ancient to modern. These haplogroups, U6 and EM78, they're common in modern North Africans.
Yes, in significant proportions, especially among Berber-speaking groups. Genetically, northern Moroccan Berbers are actually very close to those ancient Tafralt individuals.
Wow. So it's like finding living genetic echoes of those Stone Age people.
In a very real sense, yes. A large degree of continuity.
But it's not just continuity, is it? You mentioned later layers being added to the tapestry.
Right. That Iberomaurusian profile, that mix of Natufian-like and ancient North African, that was the foundation. But other significant things happen later.
Like what?
A really big event seems to have occurred around the start of the Bronze Age. There was a migration of early European farmers into North Africa.
European farmers. From where in Europe?
Genetically, they look mostly like Anatolian Neolithic farmers, the first farmers who spread out from modern-day Turkey, but with a chunk, maybe 20%, of Western European hunter-gatherer ancestry mixed in.
And they mixed with the existing North Africans.
They did. They contributed roughly half the ancestry to the existing Iberomaurusian population, so a major genetic shift.
50-50, that's huge. Was it equal mixing, men and women?
Interestingly, no. The genetic input seems to have come mainly through the maternal lines. The incoming European farmer DNA is seen much more strongly in the mitochondrial DNA than the Y chromosome.
So more incoming women than men contributed genetically, or their male lines didn't persist as much.
Precisely. The dominant paternal lineage in North Africa, that EM183, a subclade related to EM78, it remained dominant. This suggests it wasn't a simple case of population replacement.
What could explain that pattern? Incoming farmer men having fewer kids? Or something else?
Theories range from assimilation patterns, maybe local men preferentially taking incoming women as partners, or potentially more violent scenarios where incoming male groups were perhaps defeated or displaced, but their women were integrated into the existing North African societies. It's hard to know for sure.
But the result was a new genetic profile.
Yes. This mix, roughly half ancient Iberomaurusian, half early European farmer, created what we think of as the Iron Age Berber genetic profile, and that became foundational for most modern North Africans.
Okay, so that's the Iberomaurusian foundation, plus a major European farmer layer. Any other additions after that?
Several, but generally smaller contributions. We see some Levantine input, likely linked to the Phoenicians setting up trade colonies like Carthage. Some admixture with Iberians, especially in the west, closer to Spain. Then, during the Islamic era, increased contact across the Sahara brought some sub-Saharan African admixture related to trade routes and movements of people.
Right, and finally the Arab expansion.
Yes, admixture with Arab populations migrating from the Arabian Peninsula starting in the 7th century AD. Genetically, these Arab populations themselves carried a strong Natufian-like profile, so it reinforced that Near Eastern component already present.
So it's this complex layering over tens of thousands of years.
Yeah.
How does that play out today across North Africa? Is it uniform?
Not uniform, no. It's more of a spectrum, often varying east to west. For instance, people in Libya tend to show more of the recent Arab admixture, being closer to the Arabian Peninsula, whereas populations further west, like in Morocco, especially in more isolated mountain regions like Tiznet or Arcadia, they often retain a genetic profile extremely close to those ancient Berber populations. Remarkable preservation.
But despite all these layers, the original ancient foundation is still strong.
Absolutely. The overwhelming majority of North Africans today still carry significant lineages tracing back to those ancient local populations. It's a unique heritage, deeply rooted in the region, showing the resilience of those early groups.
Okay, this is fascinating. We got this deep, complex history within North Africa. But here's where, for me, it gets really interesting. You hinted that this story doesn't just stay in North Africa.
Not at all. The echoes reach surprisingly far. Unexpected places.
Let's start with one that sounds almost unbelievable. The Berber Celtic enigma. Scotland. Really?
Scotland, yes. And it starts with a tiny percentage, but a very specific marker. About 1% of Scottish men carry a Y-DNA marker called EM81.
EM81, that's the Berber marker you mentioned earlier, the one that's super common in North Africa?
The very same. Around 80% of Berber men carry it. It basically defines that paternal lineage in the Maghreb. It's completely expected in Morocco or Algeria.
But finding it in Scotland?
Yeah.
How on earth? It's not Romans, not Vikings.
Exactly. This marker, EM81, originated in North Africa over 14,000 years ago, far too old for those later historical movements. Seeing it in Scotland is a genuine anomaly, a genetic ghost from a different land.
And it's not just Scotland, is it? It follows a path.
It does. Trace amounts of EM81 pop up along the Atlantic facade of Europe, Iberia, southern France, and then up the coast to places like Orkney and the Outer Hebrides in Scotland.
Like an ancient coastal route.
It certainly looks like it. Some genetic models suggest it might have arrived in these European areas somewhere between 5,000 and maybe even 30,000 BCE, way before recorded history, hinting at very early maritime connections we've completely forgotten.
Wow. Okay, that's the father line. What about the mother line? Does haplogroup U6 show up too?
It does, and it tells a similar complex story. Remember, U6 originated in Eurasia maybe 45,000 years ago and came back to Africa around 25,000 BCE. It became the defining maternal marker for Berbers.
Right.
Well, fragments of this same U6 lineage start appearing in Neolithic sites in Spain and northern Portugal around 5,200 BCE, and faintly even in Western Ireland around the same time.
Neolithic. So
Right.
early farmers. Maybe they carried it north.
That's the idea. Perhaps Neolithic migrants moving along the Atlantic coast may be associated with the spread of cardial ware pottery, that distinctive shell-impressed pottery. It suggests a cultural and genetic bridge between North Africa, Iberia, and potentially the British Isles, way back then.
And the Canary Islands. The Guanches. How do they fit in?
They're a crucial piece. The Guanches were the indigenous people of the Canaries, isolated for centuries before European arrival. Genetically, they preserved what's called the oldest Berber DNA in the Atlantic world.
They carried both U6 and EM81.
Yes, specifically a subclade U6B1. And remarkably, this exact same U6B1 lineage also shows up in ancient remains from Galicia in northwest Spain and even in coastal Ireland.
So it looks like a triangle. Maghreb, Iberia, Ireland, Scotland.
Exactly. It hints at this potential triangular corridor of ancient maritime movement and connection across the Atlantic fringe. Roots we're only just rediscovering through DNA.
Okay, mine's slightly blown already, but there's another maternal line link, U5B1B.
Yes, and this one is even more perplexing. U5B1b was found in those very old Tarfelt remains in Morocco 15,000 years ago. Genetically, this lineage isn't native North African. It traces back to Ice Age hunter-gatherers from the Franco-Cantabrian Refuge, southern France, northern Spain people sheltering from the glaciers.
So Ice Age Europeans somehow crossed into North Africa.
Looks like it. But here's the really wild part. That exact same maternal line, U5B1b, is also found thousands of miles away among the Sami people of Lapland.
The reindeer herders in northern Scandinavia.
The very same. No shared language, no known contact between ancient Morocco and Lapland, but the same ancient mother line. It suggests an ancient population that got scattered incredibly widely during or after the Ice Age. Amazing mobility.
This is rewriting migration maps completely. What about the main Celtic marker, R1b? Does that fit in?
R1b is the dominant Y chromosome in Western Europe, especially Ireland and Britain, usually linked to steppe migrations into Europe. But there's a twist.
Another twist.
A specific branch of R1b, called R1bV88, turns up in surprising places. Across the Sahel region of Africa, Chad, Cameroon, Nigeria, and also in small amounts among Berbers in North Africa.
R1b in Africa. How? Did it go Europe to Africa?
That was the old assumption. But new research suggests a back migration, that this R1bV88 branch might have originated in or near Africa and then moved back into Europe around 7,000 years ago, maybe during that Green Sahara peak.
Reverse flow.
It really challenges the simple unidirectional models of migration.
Okay, the genetics are suggestive. Is there any physical, archaeological proof of contact between, say, North Africa and the British Isles back then?
There is some tantalizing evidence. For example, a Barbary ape skull was found in Ireland, dated to around 400 BCE.
A Barbary ape, like the ones on Gibraltar.
Exactly. Genetically identical. Now, you don't accidentally carry a live ape across the sea. It suggests deliberate transport, maybe a gift, an exotic pet, something showing direct contact centuries before the Romans got near Ireland.
That's pretty compelling. Anything else?
Yes. Something maybe even more concrete. Thousands of crushed dog whelk shells, tiny sea snails, have been found in archaeological sites in Tunisia. But these whelks aren't native. Their shells originated on the coasts of Ireland and Scotland.
Irish and Scottish shells in Tunisia. Why?
They were being processed to make Tyrian purple dye, an incredibly valuable, prestigious purple pigment used for royal and elite clothing in the ancient world.
So ancient North Africans were importing shells from Ireland and Scotland to make dye, before the Phoenicians were known for it.
It looks like it. This suggests established prehistoric maritime trade routes, not just casual contact, but economic exchange, maybe even a sense of kinship or shared connection, rather than conquest, a real Atlantic trade network.
And then the languages. You mentioned linguistic parallels that were once considered heresy.
Yes, linking Celtic and Berber. In the 1950s, a scholar named Heinrich Wagner noticed that Goidelic Celtic languages, early Irish, Scottish, Gaelic, Manx, share some really unusual structural features with Berber dialects, specifically the Zenati group.
Like what kind of features?
Things like VSO, word, order, verb, subject, object. Very rare globally. English is SVO, subject, verb, object. They also share processes like lineation, the softening of consonants in certain positions, and a root and pattern way of forming verbs, which is typical of Afroasiatic languages like Berber, but not Indo-European languages like Celtic.
So deep grammatical similarities, not just vocabulary.
Exactly. Another linguist, Vaclav Blazik, revisited this in 2003, showing deep structural resonances. For a long time, it was dismissed as coincidence. But now, with the genetic evidence showing shared haplogroups U6, EM81, maybe even R1BV88, it adds weight to the idea that these linguistic similarities might reflect actual ancient connections between the people who spoke proto-versions of these languages, language carried in the blood, perhaps.
Okay, let's switch gears to another huge linguistic puzzle, maybe even stranger. Basque and Sumerian.
Ah, yes, two ultimate linguistic isolates. Basque, or Euskara, spoken in the Pyrenees, Europe's oldest living language, no known relatives, a real survivor.
And Sumerian. Ancient Mesopotamia, cradle of civilization stuff. Ziggurats, first writing. But their language also died out, leaving no descendants.
Correct. Vanished probably around 1800 BCE. Another linguistic orphan, no known connection to Basque, separated by thousands of miles and thousands of years.
No genetic links, no trade routes, nothing obvious connecting them. And yet, people see parallels.
Uncanny parallels. Starting in the late 19th century, scholars noticed overlaps. Not just vague similarities, but specific core vocabulary.
Like what? Give me examples.
Okay, Ata for father in both Basque and Sumerian. Ura for water in Basque. Ura, or maybe or for watering flow in Sumerian. Buru for head or summit in both. Su for fire in both.
It's a pretty basic word.
Exactly. And there are over 150 such potential cognates identified in core vocabulary. Statistically, that's way more overlap than you'd expect by pure chance between two supposedly unrelated languages. It's troubling.
But vocabulary can be borrowed, can't it? What about grammar?
That's where it gets even more compelling. Both Basque and Sumerian share a very rare grammatical structure called ergative-absolutive alignment.
Ergative. That sounds complicated.
It is a different way of organizing sentences. In English, the subject of I slept, intransitive verb, is treated the same as the subject of I saw the cat, transitive verb. In ergative languages, the subject of I slept is treated the same way as the cat, the object, in I saw the cat. The subject doing the action in a transitive sentence gets a special marker, the ergative case.
Okay, so it groups things differently. It changes the whole logic.
Fundamentally, it affects how you describe actions, who did what to whom. It's found in less than 10% of world languages, often in clusters of ancient or isolated languages. Finding it in both Basque and Sumerian is highly significant.
But the genetics, he said the genetics show they're strangers, right? This Neolithic.
That's the paradox. Modern Basques are genetically distinct, descended mainly from Neolithic Iberian farmers, with that R1b-Y DNA becoming dominant later through isolation. Ancient Sumerians seem linked to other West Asian Neolithic groups, think early Anatolia with J haplogroups common. No direct genetic bridge between them for maybe 9,000 years.
So the blood says no, the geography says no.
Yeah.
Why do the languages seem to echo each other?
This is the deep question. If it's not direct contact, what is it? The leading theory points back to that shared Neolithic origin point.
The Fertile Crescent, where farming began.
Exactly. Both modern Basques, via their Iberian farmer ancestors, and ancient Sumerians derive a huge chunk of their ancestry from those pre-Indo-European West Asian Neolithic populations. Farmers spread out from that core area.
Westward to Iberia, eastward to Mesopotamia.
Right. Around 5,500 BCE to Iberia, maybe 6,000 BCE towards Sumer. This was a massive pulse of human movement carrying farming, technology, and maybe, just maybe, a shared linguistic substratum.
A kind of proto-language, or related languages, spoken by those first farmers. That later survived in isolated pockets like Basque and Sumerian.
That's the hypothesis, that the linguistic similarities aren't from direct Basque-Sumerian contact, but are echoes of a much older shared linguistic ancestor linked to that Neolithic expansion.
Are there other clues? Beyond language, shared symbols or myths?
There are suggestive parallels. Megalithic tombs, dolmens, stone circles, sometimes with similar spiral or solar symbols, are found across the route from the Levant westward to Iberia and the Basque Country. shared burial practices, maybe shared cosmology.
Mhm.
And in mythology, you see intriguing echoes. The Basque goddess Mari, a powerful earth storm goddess associated with mountains who uniquely has no temples built for her,
Okay.
is paralleled by the Sumerian primordial goddess Namu, the deep mother who birthed heavens and earth, and who also, unusually, had no temple dedicated specifically to her.
Yeah.
Shared archetypes, fragmented memories from that common Neolithic source. It's speculative, but suggestive.
And the isolation helped preserve these echoes.
Possibly. Linguistic change, drift, often slows down in isolated communities. The Basques retreated into the Pyrenees, holding onto ancient features like ergativity while surrounding languages changed. Sumerian might have left substrate influences on later Mesopotamian languages even after it died out. Isolation preserves. Contact changes.
So it leads to this deeper mystery. Could there have been a ghost population? An ancient widespread group linked to the Neolithic spread, whose language branched out and left these echoes in Basque and Sumerian.
That's one way to think about it. An ancestral population whose direct descendants are hard to pinpoint now, but whose linguistic and genetic influence is still detectable in these later isolated groups.
Or maybe it's just a shared story of survival, being the last speakers of ancient tongues, holding on to memory against the odds.
That's perhaps the more poetic way to see it. A testament to cultural resilience, to the persistence of identity and language, even when surrounded by change. Ancient DNA, archaeology, linguistics, they're all pieces of this incredibly complex puzzle.
What an incredible journey we've taken today. Seriously. From picturing that lush, green Sahara
A completely different world than today.
to uncovering this lost, unique North African lineage of Takarkori, isolated for millennia,
A real remnant population, challenging our ideas about mixing.
and realizing that huge cultural shifts like adopting herding could happen through sharing ideas, not just massive migrations.
Cultural transmission alongside genetic continuity, it's a crucial insight.
Then weaving together that whole complex, layered genetic history of North Africa itself.
Iberomaurusians, Natufians, European farmers, later influences. It's so rich.
And finally, chasing those mind-bending echoes connecting ancient North Africa to Celtic Scotland, or Basque to Sumerian. Connections that defy maps and simple histories.
It really underscores how interconnected and how surprisingly complex our deep past truly is. Ancient DNA keeps throwing curveballs at the old narratives.
It really does. The power of this science to just rewrite history, to challenge what we thought were solid barriers.
Yeah.
It's astonishing. It shows North Africa wasn't just a passive recipient or corridor, but had its own incredibly deep, complex history and contribution.
Absolutely. A center of human diversity and adaptation in its own right, with roots going back tens of thousands of years.
And the fact we can get these stories from, tiny fragments of bone, from mummified bodies preserved by desert conditions. It's like opening unexpected doors onto our shared past.
Makes you realize how much more must still be out there hidden.
Totally. This whole deep dive, it just hammers home that history is so much richer, so much stranger, and full of more twists than we probably even imagine right now.
What other lost groups, what other forgotten connections are still waiting under the sands or under the waves or even just hidden in plain sight within our own DNA?
And what will those stories teach us about ourselves?
Hmm.
About human resilience, about our incredible diversity, about our migrations and connections.
It's an ongoing discovery.
Yeah. So keep an open mind, everyone. The Sahara, our planet, our own genes, they're holding on to more secrets than we ever dreamed. Until next time, keep digging, keep exploring.
Stay curious.